पुरुषस्य रूपमधिकम् प्रच्छन्नगुप्तं धनम् विद्या भोगकरी यशः सुखकरी विद्या गुरुणा गुरुः विद्या बन्धुजनो विदेशगमने विद्या परं दैवतम् विद्या राजसु पूज्यते न तु धनम् विद्या विहीनः पशुः विद्या प्रशस्यते लोकैः विद्या सर्वत्र गौरवा विद्यया लभते सर्वम् विद्वान् सर्वत्र पूज्यते ज्ञानेन सदृशं पवित्रमिह विद्यते न हि ज्ञानेन सदृशं पवित्रमिह विद्यते न हि ज्ञानेन सदृशं पवित्रमिह विद्यते।
Dr. Hiren Dand is a highly accomplished individual who has made significant contributions to the field of information technology. He holds a Bachelor of Engineering degree in electronics and a Master of Technology degree in information technology. In addition, he has a Ph.D. in computer engineering and has also passed Maharashtra State's eligibility test. Since 2001, Dr. Dand has been serving as the head of the Department of Information Technology at Mulund College of Commerce, where he has been instrumental in shaping the curriculum and guiding students towards success. He has a strong passion for teaching, and his approachable demeanour has made him a popular figure among students. Dr. Dand is also a prolific researcher and has published 4 utility patents and 1 design patent, as well as several research papers in well-known national and international journals. His research interests include computer networks, wireless communication, and artificial intelligence. Due to his extensive knowledge and experience in the field of information technology, Dr. Dand is highly respected by his peers. He is a member of Board of Studies of IT and Data Science at the University of Mumbai, as well as various autonomous colleges. His contributions to the field of information technology have been invaluable, and he continues to inspire and guide the next generation of IT professionals. Let's welcome Vidyavachaspati, Dr. Hiren Dand.
Greetings of the day. I am Dr. Hiren Dand. I am very thankful to Part25 Association and Mulund College of Commerce for giving me this opportunity to present my Ph.D. work in front of all of you. I completed my Ph.D. in 2017 and my topic was increasing the energy efficiency of mobile phones by offloading the task to cloud. All of us know when we buy a new mobile phone, we are very happy that our battery lasts for very long. But soon, in 2-3 months, we find that we have to charge our phone several times a day. Why is that? The main thing that our battery is used up is because of the network. Whenever we are in out of range area or whenever we are doing lot of network related activities, the battery drains very fast. And these days mobile phone has become like our necessity. Originally in our school days we used to study that food, clothing and shelter are required for surviving. But these days mobile has become integral part of our life. Wherever we go, we have a lot of things on our mobile phone. So it has become absolutely necessity like our food, clothing and shelter. Without mobile, it is very difficult to even think of a day without mobile. Nowadays, new concepts like mobile fasting, electronic fasting have come up. So we have this battery should last. Everyone has that idea that battery should last for long. So my thesis was based on this, the research work was based on how we can make the battery life to last longer. So first idea came because my own phone, and I have excessive use of mobile phone. A lot of calls and messages and other things are there on the mobile nowadays. Originally there were PCs. Before that we used to have on pages and books, then PCs, and from the time mobile phones have become smartphones, most of the work happens through mobile phones. So how we can do and increase the efficiency or make our battery last longer? That was the whole idea. So the two things which I combined in the research are cloud computing and mobile cloud computing. Now what happens when our mobile, if we can do the computation and we can transfer some of the computation to the cloud, which is resource hungry calculations, computation is there. Lot of computation takes up a lot of battery time, and many things we do, if we can transfer that computation to our cloud, then it is shared and battery will last longer. So that was the entire idea of my research. Now what could be done in that? So what I did, I took 3 mobiles for running different applications. The cloud was set up using 3 Raspberry Pis, and on that 4 practical things were performed. One was about matrix multiplication from 4 by 4 to 410 by 410 matrix. So in my experiment, what I did, I performed the calculation when the computation is done on mobile itself, and then when it is transferred to cloud, how much of energy is used, how much of battery is used. So first was matrix multiplication, then there was large sorting of numbers, the third one was video conversion from one format to another, and the fourth one was file compression. Both this video and file were from 3 MB to 30 MB in increment of 3 MBs each time. So a framework was designed where whenever we want to transmit something over the network, again battery is consumed. There is latency. What is latency? When anything is transferred from our mobile phone through the network to the cloud, and when we get the results back, there is some time gap, whether that is between acceptable limits. So on the mobile side, the frameworks were designed to check whether this task can be performed faster on mobile or it should be transferred to cloud and the computation be done there. So let me explain in brief about cloud computing. What is cloud computing? According to NIST, National Institute of Standards and Technology, cloud computing is a model for enabling ubiquitous, meaning anytime, anywhere, on any device, convenient. Because of its nature, ubiquitous nature, it is convenient, on-demand network access to a shared pool of resources. On demand, whenever we need, we can use. And because there is a shared pool of resources, we can have resources, unlimited resources, infinite resources to our disposal. Whenever we need, we can get the resources. Whenever we don't need, we release the resources. And by network resources, there are servers, there is memory, there is network, there are applications, there is storage. Unlimited amount of that is up, which can be rapidly provisioned and released with minimal or no management effort or service provider interaction. There is no one sitting there that, okay, we have demanded more resources, give more resources. We have not demanded or we have finished work, release the resources. Everything is done automatic. In this cloud computing, a single person can manage thousands of servers because of its automated nature. Various software are available for managing cloud sitting in office. Of course, for Microsoft, there is Microsoft System Center. From VMware, there is vCenter. Entire package suite is available. There is Citrix. It has its own management tools. And there are third-party tools as well to manage data centers. What is mobile computing? Human computer interaction. So here it is human mobile interaction. Mobile computing, how this mobile was set up originally from 2G to 3G to 4G to 5G. How we have been using it. It deals with entire operation of the mobile, the technology shared behind it. And then combining both of these, we have mobile cloud computing, MCC. It is a combination of cloud computing and mobile computing. That is what has been my research, to combine the mobile computing and the cloud computing. From mobile to cloud, do the processing, send the results back from cloud to mobile. Seamless transmission, good bandwidth is required for that. And present day, yes, that time it was 3G. When I did way back in 2017, we had 3G networks. Of course, we used our network, lab network, to transfer the things. But that time, even from mobile, it was 3G network. So it would get transferred, time was more. So battery usage was more. With 5G, instead of from this 4x4 to 410 by 410, we could expand to 40,000 by 40,000 metrics also. But still, when we compare the results, it will be seen that the amount of energy spent, the battery used up when it is processed on mobile to then when it is transferred to cloud, because when huge matrix is there, more processing will be required. When the file size I have used from 3 to 30 MB, if we go to 300 MB, or now in GBs, now with high quality phones, the file easily runs into GBs. So to convert, to compress, the amount of energy that we use will be very high because of high quality images. Now even a mobile phone with huge cameras, we are seeing 64, 128 megapixel cameras, 120 megapixel cameras on mobile phone. Almost like DSLRs, giving high quality pictures. One image is around 4 MB in size, 4 to 7 MB. So if we go on clicking pictures, then when we need to compress them, we need to transfer them, it is going to be a huge amount of energy that is going to be used. So what happens, what we do, if it is compression, all the files will be transferred, they will be compressed and sent back to the mobile, saved in compressed format. WhatsApp and all this Telegram, they use compression. When we transfer one photo, a normal photo, when you send directly as a photo, you see the size immediately reduces. Because on that small mobile device, the resolution is not lost. If you again download that picture and see on monitor or big screen, it will be pixelated because of loss of resolution, because compression is used. The transmission is fast. So whenever we want to transmit, we know we send it as document. When we transfer as document, then the resolution is preserved. That is what now is happening. Because of huge amount of size of the file, we are transferring, the compression happens at the cloud and the results are obtained back, thereby saving lot of energy. So whenever we are transferring something from our mobile phone to cloud, the battery should be there. If battery is not at least 25%, the mobile is not 25% charged, then what might happen that while we are transferring, the network may get, phone may go off and the data will remain half transferred. So wasted all the things what we have done. So on the mobile side, it checks whether 25% battery is there, whether enough bandwidth is available for the transfer. If bandwidth is not enough, then again transfer will take very long time, the 25% battery will get discharged. So after checking that, if it is found that the battery is enough, the bandwidth is enough, and we have subscribed to the cloud service, then it will transfer to the cloud. The processing will take place and then the results will be returned back to the mobile phone. So this resource hungry processing is done on the cloud side. The battery is used only for transferring from our mobile to the cloud and the results from cloud back to our mobile phone. And seeing to it that the latency is reduced, so that we don't think that okay, we have put in processing in the morning, till evening the processing goes on, then we will feel that the things are not enough. It is all waste of time. So fast processing should happen. And through the experiments which were carried out, it was found that yes, if all these things are satisfied, lot of energy of battery is saved. So the transfer happened only if these conditions were satisfied. Number one was the battery power, 25% minimum, the enough bandwidth, and third, the cloud subscription. Then on the cloud side, there are remote executors which will execute the things, and then the results getting transferred back to the mobile device. Now this whole process took, of course, 3 mobiles were used in 2017 way back. There were limitations of, again, the RAM on the mobile phone, the type of processor which were available that time. Now things have improved. The network connectivity has gone to 5G. So things have changed. But still, we find that battery is just not enough. So today also, when we want to transfer our data from our mobile to cloud, we always save energy. With more 5G and everything becoming more resource hungry, today also the battery does not last. Initially when we take, because the applications are limited, by the time we are transferring the data from our old mobile to new mobile, it works for a while, for a day or so. And soon, once everything is done, in a day, we may have to charge the battery for 3-4 times. Out of all these 4 experiments, the first one, matrix multiplication, there was slight difference when it was performed on mobile or on the cloud. Of course, mild energy was saved. But then sorting of numbers and especially video conversion, and the fourth one, the compression, lot of power energy was saved. So battery would last longer because those are resource hungry. Lot of capacity of battery is used up while performing these resource hungry applications. So on both the sides, on the mobile side, we had our application core, this synchronizer. When we are transferring our data from our mobile phone to cloud, the data needs to be in synchrony. So that synchronizer was there, which used to combine and see that the data is synchronized. On both the cloud end and the mobile end, there were synchronizer. Then there was, of course, operating system, and mainly the experiments were carried out on Android. So that is one limitation, that it was not tested on iPhones. And of course, that time there was Windows Mobile, but nowadays everything is either Android or iPhone. So it was tested on Android, and on Android the results were shown, and iPhone uses its own optimizers, but we would certainly be able to save, because iPhone has subscription of iCloud already. So if you could transfer from our iPhone to our iCloud, we could again save a lot of energy and battery would last longer. The third one, we had a lot of hardware was of course mobile phones. Then there is framework library. What is present in framework library? A lot of libraries are required, and the programming language which I had used was of course PHP and Python. For Raspberry Pi, many things were done on Python and with PHP. There is a middleware on both cloud as well as on the mobile side. So what does the middleware do? Middleware generally does all the processing, what is required on both sides. And on the local mobile side, there is local execution manager. So if the task cannot be sent to the cloud for whatever limitations, low battery, the task is not suitable, the processing will happen faster than the latency, then it will be executed on the mobile phone. If it is executed on the mobile phone, it is done by the local execution manager. If it is transferred to cloud, the execution is done by a remote execution manager, which transfers the middleware, the processing takes place and it is returned back to the client. So that way, the setup, as I already said, there was 3 Raspberry Pi, and of course there were laptop software used to measure how much amount of energy is being used, and from mobile the data was transferred to Raspberry Pi, and then the amount of energy that was used when the processing happens on the mobile and when it is transferred to cloud to draw the graphs. Then we have the 4 experiments I already said, what we need to perform, and in the flow chart we can see the 25%. If it is performed locally, directly, no problem. If battery is not 25%, then perform locally. If there is no enough bandwidth, perform locally. If we don't have cloud subscription, perform locally. If at all everything is satisfied, transfer to the cloud, process on the cloud, and get the results back on the mobile phone. So matrix multiplication 10 by 10 to 410 by 410, sorting of numbers from 10,000 to 50,000 numbers, video compression from 3 to 30 MB with increment of 3 MB each time, and finally file compression. And then the graphs were plotted of all the results, and it was automatically and very visible from the graphs and everything that it is easily found that when task is offloaded to cloud, lot of energy is saved. The scale is different. Even if the graphs look similar, if you see the scale is different. So amount of energy saved on when the task is transferred to cloud is much more than the amount of energy saved when it is performed locally. All the four were plotted, and experiments were carried out several times to obtain the result. And once the results are similar, then the conclusion was drawn. And of course, the hypothesis that there is enough amount of energy saved when the computation is done on the cloud compared to that it is done on the local mobile. Now, what are the major conclusions were given? What can be the limitation? As I said, one main limitation is it was performed on Android phones. Secondly, what can be done? What can be the future thing of this? Now all of us have mobile phones, and we know that iOS can work on different types of CPU also. So in future enhancement, we can have a mobile phone which connects to the network. The moment it connects to our service provider, it will tell us boot iOS, boot Android, or if any other operating systems come, we can select which operating system we want to boot, and all the data can be saved on the cloud. So when we change from one phone to second phone, or from iOS to Android or Android to iOS, the data is available in the cloud. So there is no need for data migration all the time from phone. And nowadays with 5G and all, most of the places we have 4G and 5G. So with that, what will happen? The data is saved on the cloud. We can retrieve anywhere, anytime. The problem would arise only when there is no internet service. But now, even in India, very rarely we don't get the internet services. Either there is Wi-Fi or we already have our data packs. So everywhere data is available. So in future we might expect mobiles where we would have the selection of operating system. And that is really fascinating. So when I tried this, of course, as a side effect of the entire research, it was possible also to boot from cloud. The operating system resides on the cloud, and you boot. Of course, it was only with Android. You start, it picked up the entire operating system from the cloud using p.hd boot. So that is pre-execution environment, where it picked up the entire execution from the cloud. So if it can take that, if iOS is also designed like that, we can pick up from iOS also. So it will ask us which you want to boot. And of course, as this being very experimental research, the hypothesis is proved using experiment, not using the exact data and running different tests like t-tests or everything. So it was proved experimentally. So throughout this, of course, it was really fascinating to arrive at the results. And when you really get the results after doing experiments several times, it is really exciting. So that is about my research on increasing energy efficiency of mobile phone by offloading the task to cloud. So once again, thank you very much.
ज्ञानेन सदृशं पवित्रमिह विद्यते ज्ञानेन सदृशं पवित्रमिह विद्यते ज्ञानेन सदृशं पवित्रमिह विद्यते